All right, here comes the shortcut, crisscross method. Now, if you look at this example over here, aluminum is making a +3 charge. Oxygen's making a -2. If we take this number, put it after the oxygen, we now know how many oxygens there are in this compound. If we take this number, not the sign, just the number, the 2, and we put it over here after the aluminum, then we know how many aluminums there are. Let's see if this works. These guys are a 1-to-1. So anytime you have a 1-to-1, you don't have to worry about this crisscrossing. There's nothing to crisscross. It's a 1-to-1. But let's take a look over here. Calcium made a +2 charge. Actually, let me write in a different color here. How about we use this ugly green? Calcium makes a +2 charge. There's a 2 over there. Chlorine makes a -1 charge. There's a 1 over there. This pattern holds true all the time. We just didn't notice it because we were kind of working it out using logic here. But let's look at this one. Sodium makes a +1. What number is after the oxygen? A 1. Oxygen makes a -2. What number is after the sodium? A 2. This crazy one. We had to draw all these arrows and work this all out. Magnesium makes a +2 charge. That's all I need to know. If I see a 2 there, I know there's going to be a 2 after the other ion. That's how we know there's a 2 there. Phosphorus makes a -3. That 3 is going to end up down here. So now if I told you aluminum and oxygen are bonding, all you have to know is what are the charges. If you know aluminum's going to make a +3, then you know there's going to be a 3 after the oxygen. And if you know oxygen's making a -2, you know there's going to be a 2 after the aluminum. This is an awesome trick, works all the time. The only time you don't have to worry about it is if it's a 1-to-1, which means the charges are the same number. So aluminum would be like +3, and maybe aluminum is bonding with nitrogen, which makes a -3. Well, a 3 and 3, this gives up 3, this takes 3. That's a 1-to-1 ratio, so you don't use it for that. But if the numbers are different, crisscross them. So the charge on the cation, which is really the metal, it's going to tell you how many anions are in the formula, which is really the nonmetals. So if I'm looking at the cation charge, 1, I know there's going to be 1 anion, 1 phosphorus. If I see a 2 there, I know there's going to be 2 chlorines. So whatever the charge is on the cation tells you how many anions are going to be in your compound. And the flip side holds true. The charge on the anion is going to tell you how many cations are in the formula. So the charge on the nonmetal is going to tell you how many metals will be in the formula. So if I know the anion's charge is a 3, that immediately tells me I'm going to have 3 of those metals. It's going to crisscross. This is a 1. That immediately tells me I'm going to have 1 of these metals. So the numbers crisscross, and that gives you the formula. I know iron's a 3, sulfur's a -2, so I crisscross them. That 3 goes after the sulfur, the 2 goes after the iron. Magnesium and oxygen, +2, -2, that's the same ratio, so it's 1-to-1. And again, we don't have to write anything, we would just write MgO. All right, let's just practice real quick. This is where you need to look at a periodic table because you may not know the charges of things. So the first thing you do is write the symbol of the cation and the anion. So cation for potassium is K, anion is chlorine, Cl. The next thing you do is look at a periodic table. Unless you know off the top of your head, believe me, you're going to learn some of these quickly, but unless you know the charge, you got to pull out a periodic table and figure out what charge do these guys make. So here's potassium, and it's in group 1, so that means it's got 1 valence that it wants to get rid of. So potassium makes +1. So now you have to write the charge, +1. Chlorine is our nonmetal, is our anion, so I need to, there we go. Chlorine's over here. It has 7 valence, which means it needs 1 more, and it makes a -1 charge. So this works out nice because potassium and chlorine this one it has to get rid of one, this one needs one. They work out on a perfect 1-to-1 ratio, so it's just KCl. So we write the symbols, the K and the Cl. We use the periodic table to write the charges. You need to write the charges. Then you have to compare them. If they're the same, in this case it is, it's a 1-to-1 ratio. You're done. You don't have to write any other numbers. If they're different, you got to crisscross, which we'll do in a second. So magnesium, Mg, look on a periodic table, makes +2 charge. It gives away 2. Here's magnesium, +2. It's going to bond with fluorine. It gains 1, -1. So here's fluorine, -1. They're not the same, so I'm going to crisscross. Mg, imaginary 1, F2. Aluminum hooks up with sulfur. Aluminum, if you look on the periodic tables, +3. Sulfur's -2. My assumption is you know how to find these. Here's aluminum, look up, makes +3. Sulfur, look up, -2. Crisscross them, they're not the same. So we're going to do Al, take that 2, put it after it. Write the S, put that 3 after it. Finally, calcium hooks up with nitrogen, Ca +2, N -3. They're not the same. The charges are different, so we crisscross. Ca 3, N 2. That's how to write formulas for basic ionic compounds. Are there new things we're going to learn? Absolutely, but this is the basics.